Hello grade 12s. We are looking today at equations of cubic functions, specifically how do we determine the equation of a cubic function. So in the previous video we looked at if they give us the equation of a cubic function, how do I go about drawing that cubic function? And today obviously what they're going to do is they're going to give us the graph with information given on the graph, and then we have to use that information given on the graph on how to determine the equation of a cubic function. Now these equations of cubic functions, I'm actually going to call this part 1. And the reason I'm going to call this part 1 is because there's two very different ways that you can find the equation of that cubic function. And it all has to do with what they give you. So very important, we have to ask, before we try and find the equation of a cubic function, what information have they given you? So let's put that in. What information is given, and specifically that information will be given on the graph. Now I'd also just want to remind you again, the standard form of a cubic function is ax cubed plus bx squared plus cx plus d. Now you'll notice that in these examples they don't really use that format. What they sometimes do is they give you the value of a. Now if they give you the value of a, it will look like this. They will say, for instance, that it's x cubed, and then they will just, instead of putting a as the coefficient of x cubed, they'll take it over, they'll let it roll over. So they'll say it's x cubed plus ax squared plus bx plus c. So in this case, what they've done, they've given you the a value, and I really shouldn't call it the a value, I should rather in this case call it the coefficient of x cubed. So in this case, they've given you the coefficient of x cubed. The coefficient of x cubed is equal to 1. So the coefficient of x cubed given as 1. And we'll talk about that a little bit later as well. So they've given me the coefficient of x cubed as 1, and because they've given me the coefficient of x cubed, they don't need you to calculate that coefficient. And that's why they've made the coefficient of x squared, where it normally reads as b, it now reads as a, where the coefficient of x normally reads as c, it now reads as b, and where the constant value normally reads as d, it now reads as c. So I don't want you to get too fixated on these being a, b, c, and d. And the reason I don't want you to get too fixated on it is because they could go and use a not as the coefficient of x cubed, they can use a as the coefficient of x squared. And that's why you should rather go and say this a value in this case represents the coefficient of x cubed, but over here in this case that a value represents the coefficient of x squared. So don't get confused between the two. I will be very clear as to whether I'm referring a as the coefficient of x cubed or whether I'm referring a as the coefficient of x squared. So I'll be very clear in the examples about that. But like I said, don't get too fixed about the fact that the a, the b, and the c, and the d value are always going to be used in these examples in this particular way. Like I said, they can definitely use it in this manner. So, as I was saying, in order to get the equations of these cubic functions, we have to ask ourselves what information is given. And in part 1 of this particular video, we are going to look at the case where all the x-intercepts are given. So all of the x-intercepts are given, not just one of them, every single one of the x-intercepts are given. So please remember, you cannot use this particular method if they've left out one of the x-intercepts. It won't work. Then we'll have to look at the other case that I'm going to discuss in the next video. Okay, so again, shout out to Lizandi. I'm going to start with the steps, one by one. We'll work through the steps, and then when we get to the example, we're going to employ these particular steps in order to get the equation of that cubic function or the equation of that cubic graph. Now, step 1, use this particular formula. Now, this formula reads a, and now again, people, I want to state there that a value refers to the coefficient of x cubed. So that's going to be the coefficient of x cubed. So they might go and they might, in the example you'll see later on, they might use a for something else. But in this particular formula, a specifically refers to the coefficient of x cubed. Always. This always is the coefficient of x cubed, no matter what they called a in the example. Then we use x minus x1, x minus x2, x minus x3. Now this might seem familiar to you guys because if I close up that last little bracket, it actually looks identical to the formula that you use when you're finding the equation of a parabola and the x-intercepts are given. So you hopefully will recall this from the grade 11 work, that if I want to find the equation of a parabola and they give me the two x-intercepts, I use that formula. So this is only an extension of that formula saying that normally my cubic graphs do not have two x-intercepts like a parabola, it's got the three x-intercepts. So that's why I add on the extra bracket. So next step then obviously is going to be to substitute the x-intercepts into x1. So whatever the x-intercepts are, you're going to substitute it into x1, you're going to substitute into x2, and you're going to substitute into x3. Now it's very, very important to note. This is super, super important. And we have referred to this previously when we were drawing these graphs of the cubic functions. If an x-intercept is also a turning point, we have to use it twice. So if I have an x-intercept, and it's not just an x-intercept, it's also a turning point, I will take that same x-intercept and I will not only sub it into one of these brackets, I will sub it into two of these brackets. Very, very important to remember that. Then step 3, if an a value is given, substitute into a and simplify. Now, this refers to what I was talking about previously up here, meaning they could go and they could give it to you, like I said, in that format. And if they give it to you in that format, the a value has been given. They've told you in this case the a value is equal to 1. I could also go and I could put a 2 in front of there, then the a value is given as 2. I could put a negative in front of there, then the a value is given as a negative. But when I again talk about this a value that's given, I'm talking about the coefficient of x cubed. So I'm going to just write it down there so you remember that a value is the coefficient of x cubed. So if that coefficient of x cubed is given, we need to go and substitute it into that particular spot in the formula, and I need to then go and simplify, which unfortunately means you're going to have to multiply a binomial by binomial by binomial, or if I've gone and substituted twice, I might have to multiply a binomial by trinomial, which is annoying, but you've got to do it. You've got to simplify it. You cannot leave it in that format, and I'll show you in the example just now why you can't leave it in this format. Then, if an a value is not given, and this I put an asterisk on it because this rarely ever happens. I would have to say 9 out of every 10 cases, they actually give you the coefficient of x cubed, so you don't have to worry about this. But just in case, if an a value is not given, they will give you another point on the graph, and that other point will not be an x-intercept. It might be a y-intercept, it might be a turning point, but they will give you another point on the graph, and then you can go and with that other point on the graph, you can substitute the coordinates into x and y, or fx. Remember, y and fx are used interchangeably, and then you can calculate that a value. Again, I want to reiterate that a refers to the coefficient of x cubed. Right, so we're going to work through an example, and I will go and I'll refer back to these steps every single time I use one of them, just so you can see how all of this links in to how to find the equation of that cubic function. Okay, so this particular example is example 1 in the textbook, the Classroom Mathematics, on page 221. Now, they gave you the equation of this particular cubic function, and you'll recognize it as a cubic function because it's got those two turning points. And they've given you the equation saying fx, and this is the graph of f, is given as minus x cubed plus ax squared plus bx plus c, with turning points a, so a is over here, they haven't given you the coordinates of point A, so no coordinates given, and b being the point up here, b being the point 6, 0. Now, they also tell you in the information that the graph goes through the origin. So please, people, remember the origin has got the coordinates 0, 0. So if you look at this one, this is exactly what we're looking for. They've given me this x-intercept, which is the point 0, 0, and they've given me this x-intercept, which is the point 6, 0. Now again, the reason there are not 3 x-intercepts is because this is also a turning point. Now I've spoken about that when I discussed the steps. We're going to have to use this one twice. So use twice, and the reason we use it twice is because it's not only an x-intercept, it's also a turning point. So whenever we have that, we have to use it twice. Now, I also just want to refer to this. Please note they've given you the A value that I spoke about in the steps. And like I said, that A value is now no longer called A because they have now identified in this particular example A as being the coefficient of x squared, B as being the coefficient of x, and C as being the constant value. Because they've said there, my coefficient of x cubed is then equal to -1. So we will come back and we'll use that at a later stage. I just want to remind you guys that it's been given, so I don't have to calculate it. So if I go back to the steps, no, I do not have to go and calculate that coefficient of x cubed. It's been given. So later on, we're just going to use it. We're going to substitute it. So please, please, people, be careful, because the number of times I've seen people forget that in the equation, they've given me that obviously, I'm struggling to talk today, so apologies about that. They've given me that coefficient of x cubed, so I will be using it later on. Right, let's get started with the example. First thing they say is determine the values of A, B, and C. And if you look at the equation given, A, B, and C means find the equation of f. That's pretty much what they're asking for, find the equation of f. Now, because they've given me all of my x-intercepts, I'm going to use that formula that I discussed in step 1. So as I said, step 1, use this particular formula. By the way, I'm already going to go and substitute the A value in. I know it's given here as step 3, but you can actually go and do step 2 and step 3 in one go. So in one go, I can substitute the A value, or the coefficient of x cubed that's been given, and then I can also substitute my x-intercepts over there. So let's start with that. So we're going to say f of x is equal to, and now please remember this A value I'm talking about is not the A value in the equation, because here the A value in the equation is the coefficient of x squared. The A value I'm talking about specifically is the coefficient of x cubed. So I'm going to say coefficient of x cubed is -1. And then I'm going to put my 3 brackets down. Or you could actually go and you can just put 2 brackets down and make the 1 bracket squared. Because like I said, we're going to use that particular one twice. So if we're going to write it twice identical, it might actually just help to use the square. So that's what I mean with we're going to use it twice. We'll put it into that square. So it's -1 times x minus 0. So 0 obviously comes from this point given up here. And then x minus 6, and I use the bracket squared because I could have written out x minus 6 times x minus 6, but I have to use it twice because it is actually also a turning point. Now, because I've already done the substitution, I'm just going to go and I'm going to multiply it out. So multiplying it out, minus x, obviously minus 0 is just going to be minus x. And then this is quite nice and easy because it's a binomial squared. So it's x squared minus 12x plus 36. And then finally, I'm just going to distribute that negative x to give me minus x cubed plus 12x squared, and then minus 36x. So let's just double check. That's minus x times x squared is minus x cubed, and that's going to be plus 12x squared, and that's going to be minus 36x. Again, I apologize for any potential mistakes. I know Jared is probably going, ma'am. So hopefully Jared is not doing that at the moment. Okay, right. Oh, and another apology. If I haven't given a shout out to the rest of the people in my class, we'll get there. You can blame me for that when you come back after the holidays. You can totally blame me for that and come and claim a chocolate if I haven't given you your shout out. Okay, now back to the mathematics. There we go, back to the point. Okay, so back to the point. The point was we needed to work out the A value, which is the coefficient of x squared. So looking at this, my A value is equal to 12 because that's the coefficient of the x squared. We had to work out the B value, which is the coefficient of x. So my B value is going to be minus 36 because that's the coefficient of x. And then I also had to go and work out the C value, which is my y-intercept. So in this case, C is equal to 0. So it's 0 there, but it's also 0 over there, which I can clearly see. And by the way, you could go, and if you really wanted to check whether this is correct, you can substitute this equation into your table function and just check a couple of points to see whether the points reflected is also the points that were given. I'm not going to do that now. We're just going to work through this particular example. Now, this is then the equation of this particular cubic function, or the graph of this particular cubic function. Now, what they normally do then after this is they give follow-up questions, which is graph interpretation. So I know you guys don't necessarily like graph interpretation very much, but you will note that the graph interpretation questions in this particular section looks a lot like the questions that we had to answer when we sketched the graphs. So in the previous videos, when we spoke about drawing the graphs of the cubic function, you'll see it's going to be almost identical to that. So it's a nice little revision of the techniques that we learned in the previous video. So the next question in that particular example then says, determine the coordinates of point A. Now looking at point A, they gave that information saying the turning point is point A over here. So hopefully you'll recall, how do we calculate turning points of the graphs of cubic functions? By setting the derivative equal to 0, the first derivative. That, people, is very, very important for all stationary points, setting that first derivative equal to 0. So make yourself a note there that you don't go and forget, because that every single time you see stationary points or turning points, work out the first derivative, set it equal to 0. So we have now calculated the equation of that graph. Fx is equal to minus x cubed plus 12x squared minus 36x. I'm just going to copy it down over here so you can see. Fx is equal to minus x cubed plus 12x squared minus 36x. Now, by the way, you might be asking yourself, what if they ask me this question in an exam and I mess this up completely? So I do not get the correct equation at all. And then suddenly they follow up saying, now get the coordinates of the turning point. Then you've got the incorrect equation over here, which means it carries on. What they generally do in exams is they say not calculate the values of A, B, and C like they did in A. They actually go show that or prove that. So this question would normally read, show that or prove that A is equal to 12, B is equal to negative 36, and C is equal to 0. Why do they do that? So that in case you get this question incorrect, you can then use the values they've given you in the next question. And by the way, people, very, very important, because some of you can be very stubborn on incorrect answers. If they ask you to show the value of A, B, and C, as A is 12, B is negative 36, and C is 0, and you don't use the values that they've given you, you use your incorrect values that you might have calculated, people, that's just a mess. That is a mess waiting to happen. Why? Because you've made every single follow-up question more difficult for yourself. So please, I'm asking you very nicely, even if you don't get to the values they've given you, please use the values they've given you. Then another comment, you are not allowed to use the values that they've given you in this question. You're allowed to use the values in all the follow-up questions. So you're allowed to use it in B, you're allowed to use it in C. But some people try and work backwards. They try and sub these values in, and then they try and prove that it's the correct values because it gives me points on the graph. Please, please, people, you cannot do that. In mathematics, you are never allowed to use what you are supposed to prove. That is what we call a breakdown, and you will not get marks for that. So if you want to find the equation of this graph, you've got to use these x-intercepts, you've got to use this formula. This is the only way to do it. Please don't think you figured out a clever way to do it, unlike the way that I've shown you. There is no other way to do it. It's this way, and then the way we're going to discuss in the second video. This is the only way to either find the equation of the cubic function or to prove that the values A is 12, B is negative 36, and C is 0. So please, please be careful with that. Okay, hopefully that wasn't a too long side discussion and you haven't gotten completely bored with it. Right, so determine the coordinates of A. I have to find the derivative, because this is my turning point, and that's going to be minus 3x squared plus 24x minus 36. There we go. I need to now go and set that equal to 0, because that's how I find stationary points or turning points. I'm going to take negative 3 out as a common factor, so x squared minus 8x plus 12. And then I am going to divide by that negative 3, so it falls away in the next step, and I'm going to factorize the trinomial, which is x times x, and then negative 6 times negative 2. So x is equal to 2, or x is equal to 6. Now, you shouldn't be too surprised to get that x is equal to 6. Why? Because we were actually given one of the turning points b. B was the point 6, 0. So that's how I know this is the correct answers, because now I've gotten that turning point B, 6. So I'm not going to continue with this, I'm going to continue with this, because clearly that is the x-coordinate of point A. So I need to substitute it always back into the original equation to make sure that I get y-coordinates, because remember, y-coordinates you always get by subbing back into the original equation. So it's 2, so it's minus 2 cubed plus 12 times 2 squared minus 36 times 2. There we go. And that is going to give me minus 32. So A is the point 2, negative 32. And I've answered the question, which asks for the coordinates of A. Now, I agree, people, that is a big negative value. Not that you can really get a big negative value, but I hopefully understand what I'm trying to say. But remember, these drawings are not normally drawn according to scale. So it's quite possible that this is the point 2, negative 32. Now the next question then says, determine the points of inflection. Now again, that is something we did in the previous video, determining the points of inflection when we were drawing the graph. So please remember, points of inflection, we have to set the second derivative, always equal to 0. You have to know that, people, is knowledge. Okay, so second derivative equal to 0, and we find the second derivative by just finding the derivative of the first derivative. So we say second derivative of f is then minus 6x plus 24. There we go. We set that equal to 0, and we have 0 equal to minus 6x plus 24, which means 6x is equal to 24, and then x is equal to 4. Now we're not done because they want the full coordinates, so I'm going to substitute 4 into the original function again. That's how we get y coordinates. And luckily I've got that original function still on my calculator. Let's see if I can get rid of the glare. So I can just scroll back and I can change all of these x coordinates into 4. There we go. And that gives me negative 16. So the coordinates of the points of inflection is then the point 4, negative 16. Now, if you go back to the diagram, we can just put this information in, so I can just go back talking about a couple of points that I've referred to in the previous video. So we've said A is the point 2, negative 32. And we said over there the point of inflection is going to be the point 4, negative 16. Now I've spoken about this before, where you will always notice that the point of inflection lies halfway between these two x coordinates. So you'll see if I had to go and add 2 and 6, it gives me 8. And 8 divided by 2 is 4. So I know for a fact I've done this correctly. This, people, there's a symmetry always between the two turning points. And that symmetry, meaning if you go halfway between the two x coordinates here, will then always get you to the point of inflection. So again, I know I'm doing all of this correctly. Okay, so the next question, D, determine the y-coordinate of t if the x-coordinate is 3. So they're referring to this point there, which is a point on the graph, and they've given you the x-coordinate, which is 3. So I'm just trying to work out a y-coordinate, and please, people, remember, to get y-coordinates, we always substitute into the original equation, so into f. I need to substitute 3 in there. Now again, I should still have it on my calculator, so I can just go scroll back, and where I typed in 4 previously to find the point of inflection, I can now go and I can type in 3 to get the y-coordinate of that other point, which speeds things up quite nicely. So it's going to be negative 27. Negative 27, which means t is the point 3, negative 27. Then the next question is they ask, determine the equation of a tangent to the curve of t. Now we haven't done these in a while, But we did discuss, there was a whole video on how to calculate the equation of a tangent to a curve. And I also did the Luzandi method there where I said, step 1, do this, step 2, do this. So you can go back again if you've made notes, or if you've at least taken the notes that I've scanned and put onto the Google Classroom for you guys, you can go back to those notes. Now, just to let you know, we can speed this process up slightly. Why? Because we already have the y-coordinate. So I don't have to worry about the y-coordinate. But I do need to get the gradient of the tangent. And if you recall, to get gradients, we have to substitute always into the first derivative. So y-coordinates, we substitute into fx. Gradients, we substitute into the first derivative. So I know the x-coordinate at that point t is 3. So I substitute 3 into my first derivative. Now, my first derivative, I did calculate over here when I was calculating the coordinates of point A. So I'm not going to do double work. I'm just going to go and I'm going to substitute 3 in there. Please, people, do not substitute it into the latter versions because you've done algebraic changes. You've always got to go to that original first derivative. So I'm going to say it's minus 3 times 3 squared plus 24x. So it's plus 24 times 3 and then minus 36. There we go. And that's going to be 9. Now, I just want to remind you guys that answer that I got, which is 9, is not a y-coordinate. That answer which I got, which is 9, is the gradient of the tangent. So now I've got everything I need. I'm going to substitute into that formula, y minus y1 is equal to m times x minus x1. Again, if you rather use the formula y is equal to mx plus c, you're more than welcome. So it's y minus 27, so it's y plus 27. Because remember, t is the point 3, negative 27, is equal to the gradient, which I've now calculated, 9, times x minus x1, which is that 3. Which means y is then equal to 9x minus 27 minus 27, which is going to be minus 54. So that is going to be the equation of the tangent at point t. Now, if I go back over here to that point t, and I then go and I look at a possible tangent to that point, then if you look at the tangent to the point, you'll notice over here where it connects with that point t, the tangent, right over there, it's only got that point of contact. So I'm going to draw that in a different color. So you can see there is my tangent. Oops, that was a bit messy, but hopefully you get the idea. So over here, it's a point of contact, which means it only touches the graph. But if you look further up and you follow that tangent, you'll notice over here, it cuts the graph again. So over here, it's a point of contact, but over there, it cuts the graph. And that's why they have the follow-up question, which is the final question, determine the coordinates of a point where the tangent that you've just calculated again cuts the curve. So we now know that, yes, there is going to be another point where that tangent cuts the curve. And please remember, whenever we're trying to find the points of intersection of a graph, we've got to set the two equations equal. So I go minus x cubed plus 12x squared minus 36x, which is the equation of the curve, and I set that equal to 9x minus 54. I'm going to put it in standard form, which gives me x cubed minus 12x squared, and then this is going to be 9x plus 36, which is then going to be plus 45x minus 54. And you can just use your calculator to solve that. So equation mode number 4, a is 1, b is negative 12, c is 45, and d is negative 54. And I end up getting x is equal to 6, or x is equal to 3. That is not surprising because that was the point where the tangent touched the curve. That is the other point, which, lucky for us, is the point B. So I can just go, the point where it cuts again is the point 60. So thank you for listening. In the next video, I'll show you how to find the equation of a curve if the turning points are given.